So the periodic table, around the mid 1800s, we started seeing a large number of elements being discovered and introduced. And so scientists had to come up with some type of way to organize or catalog these different elements. And so around the world, people started working on periodic tables. So they wanted to have a list, an organized list of elements that existed, and there was a certain amount of design that went into them. The first one that actually got released was released by Dmitri Mendeleev, and Mendeleev organized his by atomic mass. So by atomic mass, we mean like how much it weighs. So he said, well, hydrogen is the lightest of all the atoms on the Earth, so I'm going to call that number one. And he's like, number two, the second lightest is helium. I'm going to call that number two. Later, Henry Moseley came along and he organized this a little bit differently by atomic number. And although they are fairly close in structure, there are a few changes on a couple elements. And we'll talk a little bit later about how those are organized. So one thing they wanted to do, though, was apply this periodic law. So when we look at the periodic table, we have these horizontal rows that we're going to call periods. And then there are vertical columns that are called groups. Now, periodic law basically says, well, the idea is we want to arrange this so that we'll leave holes or these gaps in the periodic table if you look at it, so that each group, each column, is going to have elements that have very similar physical and chemical properties, more chemical similarities in their chemical properties. So again, why did we leave all these empty spaces if you look at the periodic table? Why is one all the way on the left and two all the way on the right? That's so that these groups, these columns, have similar chemical properties. So if we look at the periodic table here, we can see each group has a label above it: 1A, 2A, 3A, 4A, 5A, 6A, 7A. They have 0 over the noble gases. Sometimes it's called 8, sometimes it's called 18. Depends on the periodic table you're looking at. You can see on the left side are the periods 1 through 7. So what exactly is in this periodic table? What do the boxes say? So at the top, we can see that number 6 above carbon. That's the atomic number. So the atomic number, which we'll talk about in a second, actually is the number of protons that atom has. So any atom that has 6 protons is going to be a carbon atom. The elemental symbol in the middle there is a C. A lot of those are based on Greek or Latin roots, but this one is carbon, so we use the letter C. The element name is below, and then the atomic weight or atomic mass is below that. And that's actually the average weight of all the carbon atoms on Earth, because the carbon atoms we'll talk about in a second are slightly different from one another. They all do, though, have 6 protons. That makes them carbon. So again, we said the atomic symbol is unique. It's case sensitive, so Fe is iron. It's got to be a capital F, small e. The atomic number, like we said, is the number of protons in the atom. So if it has 6, it's always going to be carbon. If it has 1 proton, it's always going to be hydrogen. So we always look at that to tell us what element we have. And when we look at the periodic table, we kind of think of the atoms as being neutral. And by neutral means it's going to have the same number of protons, positive charges, as electrons, negative charges. The number of neutrons does not affect the charge. We'll talk about those in a second, too. So the mass number, which is very important to us, we're going to talk about that when we start doing our own symbols. The mass number is the total number of protons and neutrons in an atom. We know electrons are very, very light, so we don't count them when we're calculating the mass. Most elements have different numbers, mass numbers for different atoms. So these things are called isotopes. We'll talk about those in a second as well. But if we look at oxygen, we said oxygen has a atomic number of 8. So it has 8 protons. A lot of atoms of oxygen also have 8 neutrons. But there are some that do have different numbers, maybe 9 or 10 neutrons. Those are different isotopes. So it's the same element, same number of protons, but just different numbers of neutrons. So again, we can see that they always have the same number of protons because that defines what the atom is. Different number of neutrons gives it a different mass number. On the bottom, you'll see like we have chlorine. Sometimes we'll call it chlorine 37, Cl37. There's also a chlorine 35, Cl35. And that's actually how we get the weighted average of the isotopes, because that's the atomic mass or the atomic weight that's on the periodic table. So for an example, we can see sodium has an atomic weight of 22.99 AMUs, atomic mass units. So the periodic table, we can see, was just this way to organize elements. It actually gives us a lot of information if you know how to use it. And that's what we're going to be talking about next. So these groups that have similar characteristics, chemical properties, is going to be explained in when we get into bonding and so forth.